In this video, we're going to talk about the parts of a radical and also about simplifying a radical. Okay, so just so you know, there is something called a radical, and that is this whole expression right here. They look like this. We call them, they're radical because they're kind of crazy, so radical. Okay, and they have these little parts, like they have this number before it, which we call, that's a number you should know the name of. It's called the coefficient. Okay, so that's going to go in this box right here, the coefficient. Okay, so the coefficient, that's the number before the radical. Okay, so like if I had 8 square root of 3, the coefficient would be 8. Okay, now this little number right here, it doesn't always show up, but this is called the index. Okay, and the index just basically tells you, what is it? Is it a square root of 3? Is it a square root of 5? Or is it the fifth root or the cubed root or the square root? What kind of root are we taking? Okay, for the sake of our class, we're only going to talk about radicals with an index of 2. So if the index is not written, it is automatically a 2. Okay, which means square root. So if the index is not written, it's automatically a 2, which just basically means it's a square root. Okay? This symbol right here is called the radicand symbol. Radicand symbol. That's what this symbol is called. The radicand symbol. That's this symbol right here. The radicand symbol. So on this problem here, I guess I should have talked a second ago about the index for this. The index, it's not written, so it's automatically a square root. And then the last number, the number inside the radicand symbol, is the radicand. Okay, that's the number that's being rooted, whether it's square root, cubed root, fifth root, you name it, that's what it is. Okay? Alright, so to simplify radicals, what we need to do is we need to write the prime factorization of the radicand. So remember the birthday cake method? We're going to use that to help us simplify radicals, and I'll show you how in a minute. When you're done with the birthday cake method, what you're going to do is you're going to look to see, can I find pairs of numbers? So the reason that we need to talk about index is because whatever this index is, if this were a 2, then I need to find pairs. If this were a 3, then I need to find groups of 3. So whatever this blue number is right here, that's how many I'm circling as groups. For the sake of our class, we're just talking about pairs, okay? So we would say that there's a pair of numbers right here, and then nothing else has a pair because all 3 of those numbers are different, okay? So the circled number will be, well, I'll just show you an example. So let's just start with the square root of 12. We're going to simplify the square root of 12. So what we're going to do is we are going to first do the prime factorization of 12. Now, I'm going to do some of these with the factor tree and some of these with the birthday cake method so that you can see both methods in these examples. So I'm going to find the prime factorization of 12. I'm going to start with 12 at the top of my tree, and I know that 2 goes into 12, so 2 and 6. Now, if you want to, you can take your highlighter and go, okay, 2 is prime, so I'm going to highlight it. And now 6 is divided by 2, so 2 is prime, and actually 3 is also prime. So now I've highlighted all the numbers at the bottom of my tree because they're all prime, so I'm done. So what this means is we've got 12 equals 2 times 2 times 3. Okay? So I'm going to circle one set of 2's. Okay? So since there's only one set of 2's, the square root of 12, once you circle a set, then it comes out, like we say that's a pair of 2's, so we say there's a pair of 2's, and that goes on the outside of the radical, and the 3 stays underneath. Okay? So there's one set. It comes out, we say so this out here means there's a pair of 2's inside the radical, and then 3 stays underneath. Okay? So you circle it, take one of those numbers comes out, and then what's left over stays underneath. Okay? The leftovers stay underneath the radical sign. The leftovers stay underneath the radical sign. Okay? Alright. Let's do the square root of 48. Do the same work. Okay? So 48. Let's do a factor tree. So that's 2 and 24. So I'm going to highlight my 2 because it's prime. Now let's do 24. It's 2 and 12. 2 is prime, 12 is not. Keep going. 12, that's 2 and 6. 2 is prime, 6 is not. Keep going. 6, that's 2 and 3. 2 is prime, 3 is also. I am done. Okay? So 48 is equal to 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I just want to make sure I wrote them all down. I don't want to mess up. Okay, let's circle our pairs. 2 and 2 is a pair, and 2 and 2 is a pair. And we have a leftover. What do we do with the leftover? It stays underneath. The leftovers stay underneath the radical symbol. Okay? So this means I'm going to take out a 2. Now we're multiplying here, so we're going to keep multiplying here. So the 2 comes out here. This one also gets a 2 to come out. And the 3 is left over, so it's going to stay underneath. Okay? So 48, the square root of 48 is equal to 2 times 2 square root of 3. What's 2 times 2? It's 4. So this one is 4 square root of 3. For those of you who don't like to show your work, it might be a really good idea to write down your thoughts. Okay? It gets really confusing and it's very hard to help you if you're not writing down to show your work for this. Alright, let's talk about the square root of 50. I'm going to do the birthday cake method on this one. So I'm going to say 50 starts at the bottom. Divided by 2 is 25. 25 is not a 1, so I have to keep going. Divide by 5. And then 5 needs to be divided by 5. And now I have my birthday candle at the top. What I like about this is that I don't really have to rewrite the square root of 50 is equal to this. I can circle them right here. It's real easy to see. So I have one pair. So that's going to be what goes outside. And then the 2 is not a pair, it's not circled, so it's going to stay underneath the radical. And you're done. Make sense? So one pair, so it goes outside as a 5, and then the 2 stays underneath the radical. Okay? Square root of 84. Same thing, I'm going to do the birthday cake method for this one. 84 divided by 2, that's 42. Divided by 2, that's 21. Divided by 2. Oh, no, not by 2. Let's do 3. That's 7. 3 and 7 are both numbers that are on my prime list, right? 3 and 7. So I'm done. I just need to make it 1. So divided by 7, and I get 1. So now I have my candle. Okay, let's circle our let's circle our pairs. We have one pair of 2, so that goes on the outside. What do I do with the 3 and the 7? Do I write square root of 37? No. Remember, this is 2 times 2 times 3 times 7. So that means that in between the 3 and the 7 is actually multiplication. So this is 2 square root of 3 times 7. The leftovers still stay underneath, but you multiply them underneath. So this is equal to 2 square root of 21. And that's the square root of 84. Does that make sense? Alright. Now, 1 through 4 were all radicals with no coefficient in the front. So what do we do when there's a coefficient in the front? So let's do a couple of examples like that. So we've got 5 square root of 20. So we still have to do our prime factorization of 20. Now we can do it as a tree or we can do it as a cake. I'm going to do a couple of them as a tree because some people prefer the tree. So this is 2 and 10. 2 is prime, so I'm going to highlight it. Now let's do 10. So 10 is 2 and 5, so I'm going to highlight the 2. Oh wait, 5 is also prime. I'm going to highlight the 5. So, now 20 is equal to 2 times 2 times 5. So what does that mean? Well, that means I have one pair that's going to go outside the radical, and I have a 5 that stays underneath. So I have 2 square root of 5. However, that's just my square root of 20. I still have this 5 that was on the outside. So that still needs to stay here. And what is the 5 doing to the square root of 20? That you can't even see that, sorry. What is the 5 doing to the square root of 20? It's multiplying. So we need to do 5 times 2 square root of 5, which is 10 square root of 5. Sorry, I won't use the green one again. It's really hard to see it. I can zoom in a little so you can see it a little better. But, so the 5 stayed. This is all the square root of 20. So it's 5 times the square root of 20, which is 5 times 2 square root of 5. Okay? Easy? Alright. Let's look at example 6. So example 6 says 8 square root of 72. Same thing, let's make our tree diagram, or our cake, whichever one you like better. 2 and 36. 2 and, what's 36 divided by 2? I think it's 18. Yeah, 2 and 18. And then 2 and 9. 3 and 3. So all my 2's are prime, so I'm going to highlight those to make sure I hit my bottom of my tree. Do I have all my branches filled in? I sure do. Okay, so it's 2 times 2 times 2 times 3 times 3. Okay. Next step, circle your pairs. So we're going to circle 2 times 2, and we're going to circle 3 times 3 because they are pairs. Okay, so you've got your 2 pairs that are circled. So the 2 is going to go over here, and the 3 is going to go over here. And remember, it's multiplication, so we're going to put a multiplying sign in the middle. And then this 2 wasn't circled, so it stays underneath. So square root of 2. And then this is equal to, oh, hold on, what about our 8? Don't forget your 8. So the 8 was in front of the square root of 72, so we're going to put it in front of that same thing that we just did. So we put the 8 right here. So this is 8 times 2 times 3, square root of 2. So then go to your calculator. 8 times 2 times 3 is 48, square root of 2. And you're done. Okay? Alright, number 7. I'm going to use the birthday cake method because I like it best. Because I'm going to have to keep rewriting all this junk. Alright, so 32. So 32 is at the bottom of my cake. And I'm going to divide it by 2. And 32 divided by 2, I think is going to be 12, 16? 16. Divide by 16, divided by 2, get 8. Divide 8 by 2, get 4. Divide by 4 by 2, get 2. Divide 2 by 2, get 1. And I went through that really fast. You get faster and faster at this as you go. But there's my birthday cake. So now let's circle our pairs. Holy Moses, there's a lot of pairs here. Alright, and they're all 2. Oh geez. Okay, so 2 times 2, 2 times 2, and then there's a 2 left over. So that means I'm going to have this equals, and you know what, let's just start with this. This 9 didn't disappear, so let's put it at the beginning, because we know it's going to be there. So 9. Okay, then we're going to have a 2 multiplying. We're going to have another 2 multiplying. And then this 2, remember, he stays underneath. Or she. Whatever you want it to be. And then you just multiply that on your calculator. 9 times 2 times 2 is 36. So this is 36 square root of 2. Okay? Easy stuff. Easy stuff. Alright. Last one. Let's do the birthday cake method. Oh man, this one's going to have a bunch of 5s in it. You're going to love this one. It's going to be the best. Alright, 125 divided by 5. If it ends in 5, divide it by 5. So it's 25. Then divide by 5. You get 5. Then divide by 5, and you get 1. And there's your birthday candle. Done. Okay. That's a flame, by the way, if you can't tell. Alright. So, how many pairs do I have here? Well, let's start with the fact that we have this 5 at the beginning. Let's not forget about it. So, let's go ahead and write it over here. I'm going to make it orange so I'm not confused. If you want to use a highlighter when you're working just to kind of keep track of your coefficient, because sometimes it gets confusing with that coefficient. Alright, so we've got a pair of 5s. That's going to go on the outside, so times 5. And then we've got this 5 that's left over, so square root of 5. Okay? So this 5 comes from the coefficient. This 5 comes from your pair. And this 5 is what was left over, so it stayed underneath. So now we have 25 square root of 5. Okay? And you're done with the notes. Thanks for watching.